This is part 2 of our intro to solving systems of equations simultaneously. Go back to part 1 for this. Now we're going to do a few example problems to help you see it. You should have this handout to paste into your cipher. Please paste it into your cipher on the left side of a page, just the next available page. You got plenty of pages. Go ahead and put it in. Here are the items, the steps that were listed in the earlier video as a summary for you. And now we're going to work these 3 problems. And you'll notice we're going to work them both ways, both as substitution and as columns, adding the columns. Here is the first equation, the first set of equations, the first system. We've got y equals 3x plus 2, x plus y equals 11. I'm going to try solving it by substitution first. So I'm going to look at that and I'm going to remember. I'll say to myself, okay, I remember the only point I care about is that point in the middle, right at the x where x marks the spot, me and Indiana Jones. So I know that for that point, and only for that point, these two y's are the same. Oh, by the way, this one is already got y isolated, so I'm just going to use it because it's easy. You could use any one of the 4 variables and isolate them. And if you want to do that, do it. But I'm using this one because it's already isolated. So these two are exactly the same for that one point, that purple point on the red line and the blue line that I talked about before. They are exactly the same. And this y equals 3x plus 2. That means this y must also equal 3x plus 2. So I'm going to rewrite it. I'll start writing my bottom equation. And then I get to the y. So I've got to stop there. And I'm going to write in the same thing that y equals to. And I will put in parentheses because this is a group. And there we have it. And I'll just finish copying my stuff out. Okay, there I got it. Now, this is just first week of algebra. Go ahead and solve it out. Do a little distributive property. Yep, there we go. Wrote it wrong. 7x equals 7. Or x equals 1. There we go. Okay, so we know that the x value of the point we're looking for is 1. To find the y value, we're going to take either one of our original equations and substitute the value in. I'm going to choose the top one just because it looks easier. It'll be y equals 3x plus 2, or y equals 3 times 1 plus 2, or y equals 5. There we go. That's the point of the intersection. I have solved this by substitution. Now I'm going to do the same problem using columns, which some people call elimination. It eliminates a variable. This eliminates a variable, so big what? Okay, so I'll take my 2 equations again. I'll have y equals 3x plus 2 and x plus 2y equals 11. Okay, they're not in the same order. Remember, I've got to have them all be in the same order. So I'm going to need to have an x column, a y column, an equals, and a number-only term. Okay, so I need to rearrange this one. I can rearrange that one pretty easily. I'll just subtract 3x from each side, and it will become negative 3x plus y equals 2. So I'll write that one in. Negative 3x plus y equals 2. Okay, I'm looking at this one right here, and I'm thinking, I'm not going to have a 0 pair. Remember, my goal is to have a 0 pair, so it'll go away. Matter and antimatter, poof, it's gone. So I'm seeing here that I have an x, and if I add it to negative 3x, well, I'll go ahead and put it in here so it lines up. Notice that it doesn't work. If I add these, I'll get 2x plus 3y equals 13. I didn't help. They're all still there. I got an x, I got a y. That's no good. Okay. Well, what could I do? Let's see. If this were 3x and I added it to negative 3x, poof, it would go away. That would be good. And if this were negative 2y, I could add it to positive 2y and it would be gone. Yes, yes, yes. Okay, well, either one of those will work just fine. I'm going to do the 3 just because it looks easier. Remember, okay, what I'd like to do, I want to multiply that by 3 so I can have 3x. And I can do that, but the cost of doing that is that I must multiply the entire equation by 3, not just the x, because that'll mess it up. Okay, so I'm going to multiply the entire equation by 3. That'll give me 3x, 3 times x, 3 times 2y is plus 6y, and 3 times 11 is 33. Okay, now that one's going to work. I can see down the road that I've got me a 0 pair. Now, here's a helpful hint, a word to the wise. I strongly suggest that you draw one line through the one you just changed so you don't accidentally use it. Now, don't just scratch it out or erase it because you might need it later, but just draw one line through it so you can still see what it is, but that you won't be tempted to use it. Okay, so now I'm going to add my columns. Negative 3x plus 3x is 0. Yes, she shoots, she scores. Yay! Okay. Y plus 6y is 7y. 2 plus 33 is 35. And we get y equals 5. So we know that the y value of our point of intersection is 5, and now we have to figure out the x. Substitute it back in. I'll put a 5 in here. That one looks pretty easy. 2 times 5 is 10. X plus 10 equals 11. Okay, well, x is 1. Oh, look, that's what we got before. It is the same thing. It doesn't matter which way you do it. The lines still intersect at the same place. So, next up, let's do the next problem. I don't have it here. Okay, I'll write it down. Okay, the next problem is, this is on your sheet that you pasted into your cipher, 2y equals x plus 6, and 4x plus 6y equals 4. So those are the ones we're going to work on now. Okay. Well, I'm going to do it by substitution first. Doesn't really matter which one we do. We're asked to do both of them. I look at it and I say, there's a variable, a variable, a variable, a variable. I can isolate any one of these that I want for my substitution, and it will work. Doesn't matter. So I'm looking, however, for the easiest one. I look at this y, and it's 2y. If I'm going to isolate the y, I'm going to have to divide by 2, and that's going to make a fraction. Ew, a fraction. No. If I can get away with that, I'd rather not. Okay, what about this x? Oh, hey, look, all I have to do is subtract 6, and I'll be good. I'll be home for you. I'm liking that one. Okay, what about this one, 4x? Yeah, I got to divide by 4. That'll be fine. Oh, but right there, it'll be 6 over 4. That's 1 2/3. That's a repeating. I don't want to do that if I don't have to. Okay, what about divide by 6? Okay, so to isolate y, I'd have to divide by 6, because if this y was the one I was isolating, I'd have to divide by 6. And that would be like 2/3 all over the place. No, I don't want to do that. I don't want to do that. No, 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 no. Okay. So I'm going to choose the easy peasy one. This x, I'm going to isolate. So what will that look like? I will change this. What am I going to do that? All I got to do is subtract 6 from both sides. That'll be 2y minus 6 equals x. That was easy. Okay. The x in the first equation equals the x in the second equation. And I'm going to mark it out just so I don't forget and use it by mistake. Okay, but this x equals 2y plus 6. So I can put 2y plus 6 into here and it'll still be equal. So I'll start doing that. I'll start copying this equation. That'll be 4 times 2y minus 6. So that's from right there. I need parentheses because it's a group. It's kind of like a stealth group. Okay, from here, it's just first week algebra, so that's going to be then we finish isolating our variable, and we see that that y equals 2. So we know that the point of intersection, the system solution, the y value is going to be 2. To find out the x value, we choose either one of the original equations, not the one that we've adapted. Either one of the original equations to substitute back into. Now, will it work from the adapted one? Yeah. But if you made a mistake when you adapted it, then it'll work and you'll think you're right, but it won't be right because it was wrong. You were dealing with what was wrong. So to make sure, as a check upon yourself, always use the original equations and not one that you've adapted. That way, if you've made a mistake here, you'll catch it because it won't work. So I'm going to choose, let's see, I think this one's easier. I'm going to choose the top one, and I'm going to use the original one. 2y equals x plus 6. So that'll be 2 times 2 equals x plus 6. Or x equals negative 2. So we find out that our point of intersection, the solution to the system, is the point negative 2, 2. Okay, our next example, the third one, on your handout that you should have pasted into your cipher, this is number 3. Oh, well, you know, I'm gonna do columns first. So I'll just do columns first. So this will be my x, my y, my equals, and my plain old number terms. Okay, the first one's good. It's already in the order that I need. 2x minus y equals 32. But this one's not quite. But it's not hard to fix it. All I have to do is switch the terms. Now remember, when you switch the terms, the sign has to sit with the term that's after it. So this one will be the same thing as negative 5x plus y equals 13. So that's the one I'm going to use. Negative 5x plus y equals 13. Okay, well, hey, that works pretty good, didn't it? Okay? Yeah? So what do I have here? I'll do the x's. 2x minus 5x is negative 3x. How convenient. I've got my zero pair, my matter, my antimatter. Poof, it goes away. And this will be 45. I'll go ahead and solve that out. It'll be negative 3x equals 45 divided by negative 3 divided by negative 3. So x equals negative 15. So on my solution, I know that negative 15 is the x value. To plug in to find the y value, I plug it in or substitute. And I think this one looks easier, so I'll use the top one. 2x minus y. Again, remember, always use the original. I just have the original now. This will be 2 times negative 15 minus y equals 32. Now this is where doing it in your head can get you in trouble, because a lot of people, when they do this in their head, are going to say that that ought to be 2 over there, but notice it's 62, not 2. So we know that it's negative 15, negative 62. Okay, let's try it by substitution. Here are the two equations again. 2x minus y equals 32. Y minus 5x equals 13. Okay, let's give it a go. Again, I can isolate the x, the y, the x. It doesn't matter. So I'm going to make it easy on myself. I don't want to divide 13 by 5. No, I wouldn't mind dividing 32 by 2. I mean, that would be a whole lot, but I don't want to divide 13 by 5. So I'm going to go for this y. I'm going to choose this y to isolate because it looks the easiest to me. What I'll do to do that is add 5x to both sides, and that will give me y equals 5x plus 13. Okay, so I'm not using that one. Okay, so that'll be, I'll take my top one now. This y is the same as this y, and they are both the same as this. So I'll start writing my top equation, 2x minus, and then I'm going to put in the value of y, 5x plus 13. I'll finish it out, equals 32. Oh, back to first week of algebra. Don't forget that's a minus. Why did I put a 4? I'm sorry. 3x equals 45. And I did something wrong. Negative 3x. Sorry. Negative 3x. I'm just messing up all of this. Negative 3x minus 13 equals 32. Because 2x minus 5x was negative 3x. So negative 3x equals 45. Divide by negative 3. X equals negative 15. So I know the x value of my solution is negative 15. I substitute back into the original equation. I'm going to find out that the y value is 62. So there we have it again. It is the same. Sorry about that. There we go. There we go. So, does it matter which way you use it? Which form you use? It does not. You'll always get the same answer as long as you do the same, as long as you do all your steps correctly. You don't do something like I did there and miss your sign. Okay, as long as you do your steps correctly, you will get the same answer no matter what. But sometimes it's easier to do columns, and sometimes it's easier to do substitution. Most of the time in science, it's easier to do substitution. A lot of times, like in finance or business, it might be easier to do columns because you're dealing so much with money that the things tend to line up a little bit better than they do in other disciplines. So we have here a choice. You have a choice. Every problem you work with the system, you can work either way. And again, to remind you what the steps are, if you're going to do substitution, you'll isolate one of the variables. There's 4 letters there, 4 variables. Choose either one of them and isolate it. Then you know that the x in one equation is equal to the x in the other. The y in one equation is equal to the y in the other because it's true for that one point, and that's the only point that you care about. So you just go with it. After you've substituted it in for what it's equal to in the other equation, you solve it. Then go back and substitute the value that you got, either x or y, into one of your original equations, not an adapted one. Substitute your x or y that you found into one of the original equations to get the other variable. That will be the coordinates of your solution. Okay, the other way is adding the columns. How does that work? First, you rearrange the columns so that they're all in the same order. I've recommended that you use standard form order because more commonly that's the one that works the best for this, but any form will matter. You just have to make sure that the x's are on top of the x's, the y's on the y's, the plain number terms are lined up in a column, and the equals, that's what people forget, the equal signs also have to be lined up. Then you scope it out and figure out what it's going to take to make a zero pair. You might have to multiply one of the equations by something, but you just kind of be a little math detective and figure out what it would take to either get rid of an x or get rid of a y, matter and antimatter, x and other x, so that it'll go away. Once you do that, you'll be able to accomplish your goal of eliminating one of the variables altogether. So after you've matched up your zero, you've created a zero pair for either the x or for the y. You'll add the columns straight down, and then you'll have an equation that has only one variable, either x or y. Solve it. Then, as before, take the value that you got, substitute into one of the original equations, and you'll have the answer. Okay, here endeth the lesson.